Today we're going to be looking at the 1995 AB calculus problem. Consider the curve defined by negative 8x squared plus 5xy plus y to the third equals negative 149. So we'll be looking at a series of sections of this problem. So the first one, A, find dy dx or y prime, also known as the derivative of the given equation. So in order to find the derivative of this given equation, negative 8x squared plus 5xy plus y to the third equals negative 149, we are going to have to implicitly differentiate since we are given two variables, both x and y, in this equation. So we're going to get negative 16x plus 5xy prime plus 5y plus 3y squared y prime equals 0. So using the power rule and implicit differentiation, that's how we're going to get the derivative. So as you can see, we use the power rule in negative 16x, which comes from the negative 8x squared. 2 times 8 is 16. 2 minus 1 is 1. So we get negative 16x, 5xy prime, because whenever we see a y, we multiply by y prime, plus 5y, so we use the product rule for that, plus 3y to the second times y prime, so we use the product rule, the 3 comes down, as the coefficient, 3 minus 1 equals 2, so it's squared, and we multiply by y prime, and it's going to equal 0. So we're going to use the basic algebraic rule in order to find y prime. So we're going to start by factoring out y prime. So we're going to have y prime multiplied by 5x plus 3y squared equals 16x minus 5y. And then we're going to do another basic algebraic rule and divide by 5x plus 3y squared. Divide 16x minus 5y by the 5x plus 3y squared in order to solve for y prime. So we're going to get y prime is going to be equal to 16x minus 5y divided by 5x plus 3y squared. That's going to be our derivative, or dx dy. So next, B, write an equation for the line tangent to the curve at the point 4, negative 1. So we have an ordered pair given in this problem, 4, negative 1. So to find the equation of the tangent line, we must use point-slope form, which is seen as y minus y1 equals m multiplied by x minus x1. So in this ordered pair given over here, we have 4, negative 1. So that's going to be, the 4 is going to be seen as our x1, and the negative 1 is going to be our y1. So again, x1, y1 is the ordered pair 4, negative 1, and then m here is equal to the slope. So step 1, evaluate dy dx at 4, negative 1. So using the derivative that we just found, plug in the x value 4 and the y value negative 1 to find the slope. Because ultimately m is equal to our slope, and slope is the derivative. So 16 multiplied by 4 minus 5 multiplied by negative 1 all over 5 multiplied by 4 plus 3 multiplied by negative 1 squared. So that's going to give us 64 plus 5 over 20 plus 3, and that's going to equal 3. So m is going to equal 3, which means our slope is going to equal 3. So B continued. Step 2, using point-slope form, write the equation by plugging in 4, negative 1, and the slope, which we just found is 3. So using the point-slope form, we're going to use our ordered pair, 4, negative 1, and the slope that we just found, 3, and that's going to be equal to y plus 1 equals 3 multiplied by x minus 4. Now, some people like to give this in the form of y equals mx plus b. You can do that also. In order to do that, you're going to distribute through so the equation is given in that form of y equals mx plus b. You're going to have y equals 3x minus 13. C. C tells us that there's a number k, so at the point 4.2, k is on the curve. Using the tangent line, approximate the value of k. So k can also be seen as the value of y in this, question. So plug in the value 4.2 for x in order to find y or k. So we're going to use the equation that we just found in B in order to find k. So we're going to get y plus 1 equals 3 multiplied by 4.2 minus 4. So we have the slope here, 3, and then we have the 4.2 as x, and then 1 and then negative 4 as the ordered pair that was given to us in the last problem. So 4.2 minus 4 is obviously 0.2. So you can see that there, and then you're going to get the answer as negative 0.4. So k is going to be equal to negative 0.4 as an approximation. D. Write an equation that can be solved to find the actual value of k, since the last one was just an approximation, so that the point 4.2k is on the curve. So we're going to start by plugging in the value 4.2 into the original equation as x. So the original equation that we saw on the very first slide of this video. So that's going to look like this. Negative 8 multiplied by 4.2 squared, can't forget the exponents, plus 5k multiplied by 4.2 plus k to the third equals 149. So once we multiply this through, it's going to be k to the third plus 21k plus 7.88 equals 0. So that's going to be the equation, because remember, we're just trying to find an equation here that can be solved to find the actual value. So we have the equation there. B, this is our last one. Solve the equation found in part D for the value of k. So for this problem, we're going to need our TI-84 calculator. And you're going to plug the equation that we just found, k to the third plus 21k plus 7.88 into the y equals tab of the calculator in order to solve for k. So I would just substitute x in for k when you plug it in, just to make things easier. And then after, a graph is going to appear once you hit graph. So when looking at the graph, find where the line meets the x-axis. That is the value of k. So you're going to look where the function meets the x-axis on the calculator on the graph, and that's going to be your value of k. So using the up and down arrows, you can move over the little arrow, I guess you could call it, to try to find that value. And so your value of k should be negative 0.303. And that concludes how to solve this AP Calculus exam problem. But lastly, enjoy this photo of myself and the one and only Sean Tierney, because AP Calc rocks and Tierney also rocks. And I hope you enjoy this video. Thanks for watching.